Hey guys, this is going to be video for the 3.6 homework. Let's do it. 3.6 is very similar to 3.5. And the only difference is that you potentially have, there can be potentially imaginary solutions rather than just real solutions. So, let's go through here. Identify the number of solutions of the polynomial equation, then find all the solutions to the equation. So when I look at the first one, I see x to the third plus 64. So because this is a third degree polynomial, it has 3 solutions. It's going to have 3 solutions. Those could be real, imaginary, irrational, rational. So that's kind of what we are going to be find. We're just going to find all 3, regardless of what kind of zeros that they are, or solutions. So x to the third plus 64. I know what we can do here. There's a factoring pattern for the sum of 2 cubes, and that pattern goes a plus b times by a squared minus ab plus b squared. And so in this case, we'll use this factoring pattern. So we're going to take this, we're going to factor it into these 2 factors accordingly, and instead of a, we're going to use x, and instead of b, we're going to use 4, because 4 cubed is 64. So this is going to be equal to x plus 4. And then we're going to have x squared minus 4x plus 16. And here I can see the 2 factors. Now the 2 factors, their zeros are going to add up to be the number of solutions. So this factor is going to have 1 solution. This factor is going to have 2 solutions. This factor right here I can solve for. I can see that the value that would make this equal to 0 would be -4. So x has to be equal to -4. Here's one of the solutions to this equation. I need to find the other 2. That's going to come from this factor right here. Now, I've said this before, but whenever you factor a sum or a difference of cubes, what you get left over, so this part right here, is not factorable. You can't factor this. There are no 2 numbers that are going to multiply to 16 and also add to be -4. So there's no such pair of numbers that exist. So what we have to do, if a quadratic, which is what we have, is not factorable, then we have to use the quadratic formula. So in this case, the quadratic formula, we need to identify the coefficients. So the first coefficient is 1. That's going to be the coefficient of this term right here. The next coefficient is -4, and the third coefficient is positive 16. So this is what we're going to use for the quadratic formula. So x is equal to the opposite of b, so that's going to be positive 4, plus or minus the square root of b squared. So if I square this, that becomes positive 16. So 16 minus 4 times by a times by c, and everything's going to be all divided by 2a. So we're just going to go through, and now underneath here, we are going to simplify this part right here. So 16 minus 4 times 1 times 16. So I'm going to multiply these 3 terms together first. So -4 times 1 is -4, and -4 times by 16 is 64. So this becomes 4 plus or minus the square root of 16 minus 64 over, I don't know why I put 2a there. That's just going to be 2. That's just going to be 2. That's just 2 times by 1. There we go. Okay. And then to finish this right here, 16 minus 64 is -48. So we're going to get 4 plus or minus the square root of -48. So -48 all divided by 2. Okay. Now what we're going to do is deal with this radical right here. I have a negative in this radical, which I do not want a negative underneath the radical. And so what I can do from here, so 4 plus or minus, we're going to say I square root of 48. Because remember that I is equal to the square root of -1. So if I take out a square root of -1, or I kind of simplify that, it just becomes I, which is an imaginary unit. It's not saying it's fake, it's just a different kind of a number. Kind of like negatives and positive numbers. They're different kinds of numbers. All divided by 2. Now, I'm going to focus on the 48 because I'm going to simplify this radical. I can't take the square root of 48 evenly, so are there any factors of 48 that I can take the square root of? And 48 is divisible... Is it divisible by 16? Yes, it is. So, to simplify it more, we're going to 4 plus or minus I square root of 16 times by 3 divided by 2. 16 times by 3 multiplies to be 48. And then I can look at the... So I'm taking the square root of 48 right here, but I'm changing 48 to be 16 times 3 because I can take the square root of 16 and leave 3 in the square root. So this is going to end up being 4 plus or minus, the square root of 16 is 4, so I'm going to put that outside where the I is, square root of 3 divided by 2, and finally, I can divide both of these by 2, so this is going to be equal to 2 plus or minus 2I square root of 3. And these are the other two solutions. So we have these two solutions right here. This one and this one these two right here. This is 2. The reason why it's 2 is because we can do 2 plus this expression right here, and we can do 2 minus that expression right there. So there you go. We have our 3 solutions. Next up, we're going to do this one right here. So again, first thing we're going to default to is to do some factoring. So I can take out an x squared, and I'm going to be left with x to the 4th minus 1. Okay, and I'm still looking to factor, so I can factor this right here. So I have x squared. This can turn into x squared minus 1 and x squared plus 1. And then this can factor even more. So I can change that to be x plus 1 and x minus 1. And then we have x squared plus 1. All this is equal to 0. So now we're going to identify what value of x these need to have in order to make them 0. This just has to be 0. So x is going to be equal to 0, but this is going to be by a multiplicity of 2. Okay, so there's 2 solutions right here. Oh, also, we're going to have 6 solutions. Okay, we're going to have 6 solutions, so multiplicity of 2, because that is 2 factors where x can be equal to 0. Next is going to be x is going to be equal to -1, x is going to be equal to +1. So now we're at 4 solutions. We have 1, 2, 3, and 4. The last 2 solutions are going to come here. This is not factorable, so I'm going to solve this one. It's only a binomial, so I don't have to use the quadratic formula. So I'll just say x squared plus 1, set it equal to 0. I'm going to subtract 1, so I get x squared is equal to -1. I'm going to take the square root, so I get x is equal to, don't forget to use plus or minus the square root of -1. And the square root of -1 is I. That is the definition of the imaginary unit. So x is going to be equal to plus or minus I. And there's 2 solutions there. So we have 2 imaginary solutions, 4 real solutions, 2 of which are 0 because of a multiplicity of 1, -1, and 1. So there's all 6 solutions there. All right, for 3, we're going to have 5 solutions. So we're going to have 5 solutions. So I think I'm going to try and do some factor by grouping here because I see 4 terms. So let's go ahead and give that a go. I can take out an x squared. I'll be left with, I can take out an x cubed. And I'll be left with x squared minus 1. I can take out a -1 here, and I'll be left with x squared minus 1, so factor by grouping works. They both have a factor of x squared minus 1, so I can factor that out of those sides, both sides, and I'm going to be left with x to the third minus 1. Okay, and then I can factor this, and I can factor this. This is a difference of cubes, so I'm going to use the same type of factoring pattern that I used up here, and this is a difference of squares. And so we're going to have x plus 1, x minus 1, so that's coming from these two. I'm going to factor that into those two, and then this one's going to factor into x minus 1, and then it's going to be x squared plus x plus 1. So these two factors are coming from this factoring pattern that I specified up here, except the signs are going to be different for those two spots because this is subtraction rather than addition like we had up here. But that's how that's going to factor into those two right there. So I can identify three solutions here. So x equals -1 and x is going to be equal to +1. This is by a multiplicity of 2 again, so I have two factors that are x minus 1, so that's going to occur twice. And now here, not factorable, so I have to use the quadratic formula. So identify the coefficients, so a is going to be 1, b is going to be 1, and c is going to be 1. So using the quadratic formula with those, so we're going to say x is equal to the opposite of b, which is -1, plus or minus the square root of b squared. So 1 squared, that's just going to be 1. Minus 4 times by a times by c, all divided by 2 times by a. So this shouldn't be too hard to simplify. So -1 plus or minus, we're going to have 1 minus 4, which is just going to be -3. Okay, all over 2. Deal with the negative in the radical here by factoring out that I. So -1 plus or minus, we're going to say I square root of 3 over 2. And there's nothing else I can do to simplify that, so there we go. So there's two solutions right here. 2 because we can add or we can subtract that term right there. So we have 2, 3, 4, and 5. So there's all 5 solutions. Okay, find all the zeros of the polynomial. So really not changing anything about what we're doing. We're just gonna, but in this case right here, notice that a 0 is already given to us. So this is gonna have 4 solutions. We have one of them. So we're gonna use synthetic division. So 4, if I remember correctly from last year, I'm pretty sure I typed in one of these wrong. So I am going to need to graph these really quickly to make sure that what I have written here is okay. Let's see, so 4 is a solution here. So let's go ahead and use that with synthetic division. So 1, -6, 7, 6, and -8. Do I need any placeholders? 4, 3, 2, 1, 0. No. So 1 times 4 is 4. That's going to be -2, -8, -1, -4, 2, 8, 0. So this is x to the third minus 2x squared minus x plus 2. Okay, so I have 4 terms. I think I can do some factor by grouping with that right there. So I can take out x squared, be left with x minus 1. I can take out x minus 2, sorry. X minus 2, I can take out a minus 1, and I'll get x minus 2. So they both have x minus 2, and I'll be left with x squared minus 1. And then, so x is going to be equal to 2. There's one solution. This can be factored to be x plus 1 and x minus 1. So the other solutions are x equals -1 and x equals +1. So in this case, we have these 4 as our solutions. None of them are irrational. None of them are imaginary, so that's nice. Okay, let's try this one right here. So this is a third, this is a fourth degree, we're gonna have 4 solutions. We're gonna divide, use synthetic division with 3. I'm gonna make sure that this is that I give the right number here. Did I type that in right? That's gotta be to the 4th. 3, okay, 3 works here. Okay, so we're going to use 3. 1, we need a placeholder for the x cubed term, because there's no x cubed term. Then -9, -4, and 12. Drop the 1. 1 times 3 is 3. Add 3. That's going to be 9. That's going to be 0. 0 times 3 is 0. -4, -12, and 0. So this polynomial, x to the 3rd plus 3x squared, and then -4, and that's going to be equal to 0. So the problem here is that is not factorable. It's not a quadratic, so I can't use the quadratic formula, so I need another 0. I'm going to use the rational roots theorem, if you guys remember that. So I'm going to take the factors of -4 and divide it by the factors of 1. So I can have plus or minus 1, 2, 3, or 4 over the factors of 1. So the other zeros could be 1, it could be 2, or it could be 4. So I'm going to plug in 1 into this function right here and see if I get 4. So if I plug in 1, I'm going to get 1 plus 3, because if I plug in 1 right here, that just becomes 1, and then -4. Does that equal 0? So 4 minus 4, it does equal 0. So I know that 1 is a solution. I think I got a little lucky right there. So I'm going to use 1, and I'm going to use synthetic division again. I'm going to save some space right here. I'm just going to use this same part right here. So I'm going to use 1. So double synthetic division. Drop the 1. 1 times 1 is 1. 3 times, that's going to be 4. 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 That's going to be 0. That's going to be 0. That's going to be 0. Okay, so then here's the next polynomial. We're going to have x squared plus 4x plus 4. Okay, so I still need the last 2 solutions. They're going to come from here. This is factorable. This is going to be factored into x plus 2 and x plus 2. So they're the same factors. So I'm going to get a solution of x equals -2, but with a multiplicity of 2. Happens twice, so there's the last 2. So here's 2, 1, 2, here's 2, 3, and 4. Okay. Let's try 6. So for 6, let me just graph it, make sure that x equals -1 is a solution. X equals -1 is a solution. Okay, so let's go ahead and do synthetic division. We're going to have 1, 4, 7, 16, 12. No, 4, 3. So 4, 3, 2, 1, 0. Okay. Drop the 1. So 1 times -1 is -1. 4 and -1 is going to be 3. -3, 4, -4. That's going to be 12, -12, 0. So I have x to the 3rd plus 3x squared plus 4x plus 12. I think I can do factor by grouping here. It looks like I can. I can take out x squared, and I'm going to get x plus 3. I'm going to take out 4, and I'll get x plus 3. So I'm going to have x squared. I'll put this underneath. So I'm going to have x plus 3, and then I'm going to have x squared plus 4. Perfect. Okay, and so I can identify another 0 here, so x has to be equal to negative 3, and then I can identify, so well here this is not factorable, so I'm just going to set that equal to 0. I'm going to subtract 4 to the other side, so I get x squared is equal to negative 4. I'm going to take the square root, so I'll get plus or minus the square root of negative 4. Now I do know the square root, I have a negative in here, so I need an imaginary unit. I also know that the square root of 4 is 2, and so x is going to be equal to plus or minus 2i. So there we go. We have 1, 2, 3, and 4 solutions right there. Okay, so for this one right here, let me make sure that these are good. So we have 5 plus 3 minus 4 minus 2. Oh my gosh. So many terms. So we said x is equal to 2, negative 4. Okay, no, we're good. So let's go ahead and now I'm giving you 2 zeros to use here. So we're gonna use synthetic division twice. So we're gonna use 2, 1, 3, negative 4, negative 2, negative 12, 16. So 1 times 2 is 2. That's going to give me 5, 10, 6. That's going to give me 12, 10, 20. That's going to be 8, 16. That's negative 16, 0. Okay, now before I write out a polynomial, I'm going to use negative 4. It doesn't matter in which order that you use these either. So I'm going to divide again with 4, so drop the 1, that's negative 4, that's 1, negative 4, 2, negative 8, that's going to reduce to be 2, negative 8, 0. Okay, now we divided twice because we used synthetic division twice, and so the degree of this term is going to be 2 degrees less than the degree of that term. So this is x to the third plus x squared plus 2x plus 2. And I'm going to do some factor by grouping. I can take out x squared, I'll get x plus 1. I can take out 2 right here, and I can get x plus 1. So I'm going to have x squared plus 2 and x plus 1. And so this is going to give me a solution of x equals negative 1. This right here, I'm going to set equal to 0. And solve, so I'm going to subtract 2, so x squared is going to be equal to negative 2. Take the square root, so x is going to be equal to plus or minus the square root of negative 2. I can't take the square root of 2, but I can take the square root of negative 1 by using I, and x is going to be equal to plus or minus I square root of 2. So there's the last 2 right there. There's the third, fourth, and fifth. Determine the number of imaginary zeros for the function with the given degree and graph. So when I'm looking at this graph right here, it tells me that this polynomial is of degree 4. And that kind of checks out. I think it does look like it's degree 4. But I can see that it only has 2 x-intercepts. So that means that if there's only 2 x-intercepts and the degree is 4, it needs to have 4 solutions, but only 2 of the solutions are going to be real. So here's one real solution right there. Here's the other real solution. So that means that there has to be 2 imaginary solutions. So there's going to have to be 2 imaginary zeros. Because I see 2 real, and then I don't see 2 others, so, and the degree is 4. In this case right here, so the degree of this polynomial is 2, and how many imaginary solutions or zeros does it need to have? It's also going to have 2. So both of the solutions to this graph, or to this polynomial, are going to be imaginary. So same, 2 imaginary zeros here. because it doesn't have any x-intercepts, which x-intercepts are will show up if they're real. Okay, and finally, so we have these last two right here. So we've done these problems before in 3.5, but with irrational, we are also going to do this with rational or imaginary solutions. Imaginary solutions always come in pairs. Always, always, always. Here's 2, and here's 2. Here's 2, and here's 2. And the pairs that they come in are always conjugates. So here it tells us that here's a polynomial, and the zeros are 3 and 4 plus I. So they only gave us 2. But they also gave us 4 plus I, which means the other solution has to be 4 minus I. This has to be a solution because I can see that its conjugate, 4 plus I, is a solution. And we are going to be multiplying all of these together in order to get the polynomial. That's the objective of these problems right here. So I'm going to make them into factors. So if x equals 3 is a solution, x minus 3 is its factor. And then x minus 4 plus I is a factor, and x minus 4 minus I is also a factor. So these factors come from these zeros right here. So always x minus. Always use x minus, and then 4 plus I, 4 minus I. Okay. So what we're going to do first is multiply the imaginary factors together, because we want to actually get rid of imaginary units, and that's only going to come from multiplying the conjugates together. So let's go through this. So we're going to take x and multiply it by all three terms over here. So that's going to be x squared. X times by negative 4 is negative 4x. X times by negative I is negative xi. Okay. Now negative 4, multiply it by all three terms over here. So negative 4 times x is negative 4x, and I'm going to stack that with my already current negative 4x. So I got negative 4x from multiplying these together. Now I'm getting it from multiplying these together. Then negative 4 times by negative 4, that's going to give me positive 16. So I'll put that here. Then negative 4 times by negative I, that's going to give me plus 4i. Okay, now on to this last one. So I times by x is going to be positive xi, and I already have a negative xi from before, so those are going to cancel. And then I times by negative 4 is negative 4i, but I already have a positive 4i, so those are going to cancel. And then positive I and negative I is going to become negative I squared. And I'm going to put that underneath the 16, and I'll show you why in just a bit. So let's go ahead and add these together what we can. So we have x squared minus 8x. These are going to cancel. And then we're going to get plus 16 minus I squared. Now I squared is equal to negative 1. And so I'm going to be subtracting negative 1. I squared is equal to negative 1, so this is minus negative 1. This becomes plus 1. So that's why I'm going to combine it with this 16, and then instead of writing 16, this is going to become plus 17. So there's the polynomial there. I'm going to bring down this x minus 3, and I'm going to multiply these together right here. So this is going to become x to the third. When I multiply those, then I'm going to get minus 8x squared plus 17x. Now I'm going to go to the negative 3. I'm going to get negative 3x squared. Negative 3 times negative 8 is positive 24x. And then negative 3 times 17. 3 times 17 is 51, so minus 51. So I'm going to get x to the third minus 11x. 24 plus 17 is going to be plus 41x, and then minus 51. So this is a polynomial that will give you these solutions right there. Let's try this again. We're going to have 3i and 2 minus I. So if 3I is a solution, negative 3I, its conjugate also has to be a solution. If 2 minus I is a solution, then 2 plus I is also a solution. So the factors we're going to have is x minus 3I, x plus 3I. We're going to have x minus 2 plus I, and we're going to have x minus 2 minus I. Now, these right here, if I FOIL, in fact, when I FOIL these out, I'm going to get x squared. These outer and inner terms, so those are going to cancel because they're conjugates. And then I'm going to get negative 3I plus 3I. When I multiply those together, that becomes minus 9I squared. And I squared is negative 1, so this becomes x squared minus 9 times by negative 1. So that becomes x squared plus 9. Okay, and then I'm going to multiply these together. And so when I multiply these together, I'm going to get x squared. X times by negative 2 is negative 2x. And x times by negative I is negative xi. Negative 2 times by x is going to give me negative 2x. Negative 2 times negative 2 is going to give me plus 4. Negative 2 times by negative I is going to give me plus 2I. Okay, and then I times by x is going to be plus xi. I times by negative 2 is going to be negative 2I. I times by negative I is negative I squared. So kind of the same pattern that we saw before. We're going to get x squared minus 4x. Those cancel. And then this is 4 plus 1. Because negative I squared is negative 1, negative I squared is plus 1, so that becomes plus 5. So now I'm going to multiply these together right here. So x squared times x squared is going to give me x to the 4th. X squared times negative 4x is negative 4x to the 3rd. X squared times by 5 is plus 5x squared. 9 times by x squared is 9x squared. 9 times by negative 4 is going to be negative 36x. And then 9 times by 5 is going to be plus 45. Did I get everything? Right, so 1, 2, 3. I get 3 terms here. 1, 2, 3. Get 3 terms there. Okay. So we're going to have x to the 4th minus 4x to the 3rd plus, then we're going to have 9 plus 5. That's going to be 14x squared minus 36x plus 45. And yeah, I think that's it right there. I think I took these problems off of your homework. Hopefully I did, because I don't want to talk about Descartes' rule of signs. Cool. All right, that should be everything for this homework.